Hello guys, my name is Balkrishna Srivastava and welcome to Code with PK. So in this video, we write a Java program to implement a Shift Cipher. We solve this assignment to decrypt and encrypt a message. So before we begin, it is a request to please subscribe to my channel because out of 100 views, only 3 or 5 are subscribed. More than 95% of my audience is not subscribed and a subscription is very important. So please do subscribe to my channel. So let's begin. So we have to write a Shift Cipher. Okay. So you have to prompt for encrypting or decrypting, and if the user enters anything apart from one or two, you display the following message: invalid selection. Okay. Then you have to choose a numeric key for your cipher. So Shift Cipher basically shifts the characters right or maybe left, you decide, right? We usually shift right. So the shift is by some number of characters, which is your key. Okay. So you cannot enter a key less than one. For example, if you enter 0, so you basically encrypt into the same character, which does not make sense. Okay. So a numeric key does not have to be less than 1 when you are trying to encrypt. Okay. Similarly, when you're trying to decrypt, the numeric key, okay, in that case we shift the other way. So if we are shifting right for encryption, we shift left for decryption. Okay. Display invalid message if numeric key is less than 1. Okay. So these are the list of characters which are to be encrypted, which include uppercase characters, lowercase characters and digits. Any character apart from this is added as it is to the decrypted / encrypted message. Okay. So if the input is this, all right, I choose 1 for encrypting. Okay. So I choose encryption as the output. Choose a numeric key for a cipher. I input 3. Okay. So output is this. Okay. I'll explain you how. And similarly for the second case, when I have the same this, okay, which I encrypted from the previous case, I decrypt it using the same key. Okay. The shift has to be the same. So I get my original message. Okay. Similarly for the second case. Okay. All right. So in my main, okay, first the characters that we have to encrypt. Okay. So string characters. Okay. This is your this message. Okay. So we have to enter 1 or 2 for, we have to enter the message first. Okay. So ask the user to enter a message. Okay. So in order to read input from the user, create a scanner object. Okay. Scanner equal to new scanner system dot in. Okay. Import java.util.scanner. Okay. Close the scanner because closing the scanner is a good coding practice. Scanner dot close. Okay. Uppercase S. Okay. As I enter the user the message, so the prompt here is please enter a message. Okay. So sys out without changing a line, please enter a message space. Okay. As a string input message. Okay. So the input message can be to encrypt or to decrypt. Okay. So that's why I'm using the variable name input message. That is the input from the user. Scanner dot next line. I read the entire line. Okay. So we read this message, and you can add a further check that this message does not have to be blank. So you can say maybe to do add check to ensure a blank line is not input. Okay. So ignore these squiggles for now. Okay. We have taken the input message. You have to choose enter 1 or 2 for encrypting or decrypting. So I say sys out enter 1 for encrypting and 2 for decrypting this thing. Okay. Okay. And do not change a line. Okay. So I'll say int user choice is scanner dot next int. Okay. And since we are using next int after next line, this is okay. Next line will use the entire line including the change in line character, so you can use next int. So if there was next line used after next int, then we would have to handle the extra change in line character. So I've already uploaded a video where I explain in detail how to use next line and next int together. In this case, we don't have to do anything else. Okay. All right. Okay. Then ensure user choice is 1 or 2. Okay. While user choice is not equal to 1 and user choice is not equal to 2. Okay. Show error. Okay. And what was the message? Invalid selection, this thing. Okay. Sys out. Okay. And we print, not print ln, and then we read the choice again. Okay, so by the time we are here after this while loop, we can be sure that user choice is either 1 or 2. So if the user choice is to encrypt, if user choice is 1, okay, else if user choice is 2, else if user choice is to decrypt. Okay, so oh, you have to choose, you say show message, so sys out you, okay, you chose encryption, you chose encryption, and a dot. All right, similarly for this case you chose decryption. Okay, so let's just code this encryption first. So for encryption we enter 1, okay, and choose a numeric key for your cipher. Okay, so I say sys out choose a numeric key for your cipher, and I say int numeric key is scanner dot next int. Okay, all right, so this next int will be after this next int call, which is okay. Okay, while numeric key is less than 1, we are not allowed to have numeric keys less than 1. So for that we have to print the message, you must choose, please enter numeric key, this thing. Okay, all right, so I say sys out, okay, and I read this numeric key again. Okay, now we encrypt, and we can do this exact same thing for decrypt. Okay, choose a numeric key for a cipher. What was the prompt for decryption? Please enter the numeric key for a cipher. It's just a very trivial difference, right? But I'm gonna go with the requirements, right? Okay, change a line, and if the input was invalid, you say you must have the numeric key to decrypt. Okay, this thing. Okay, this is for description. Okay, and then we decrypt. Okay, all right, so shift ciphers will get a numeric key. For example, if my input message M is cricketer, okay, the set of characters that we have is uppercase A B till Z, then lowercase a b c d till e f g h I j k l m x y z, then 1 2 3 till 90. Okay, that's what we have, right? Okay, so we have to encrypt, okay, using a shift cipher. Okay, and suppose our key is 3. Okay, so what you have to do is you have to replace every character by a character that you get by shifting 3 places from this string. So this part will be a b c d e f g h I j k l m n o p q r s t u v w x y z. Okay, so you have to find a character 3 places right. We usually shift right for encryption. You can choose left as well, we usually do right. So you have to replace C by a character that is 3 places after, because the key is 3. So 3 places after is D, E, F. So this becomes F. Okay. Then you have R. After R we have 1, 2, 3 U. Okay. After I we have J, K, L. F, U, L. It would be F, U, C, and then it goes wrong. Okay. Then I have C again. So C, F, and again F. Then I have K. So for K we have L, M, N. Okay, and for E we have F, G, H. Okay, for T we have U, V, W. Okay, for E we had F, G, H. Okay, for R we had U. Okay, so this is the encrypted message by using this key and a shift cipher. Okay, so if you had Z, plus 3 would go out of bounds. So in this case, plus 3 would make you reach here at 3. Okay, so you add plus 3 to Z, you get 1 2 3 digit 3. Okay, and if you are at the last character, say 0, plus 3 would take you to the starting from the first 1 2 3. Okay, so if you cross the boundary, you start from the first. Okay, that is how it works. Right, so I'll say the string encrypted message is a blank. Okay, so in order to encrypt, we iterate this string from left to right. We pick up each character and we find the corresponding character after shift cipher. Okay, and we will not have all the characters in this string, so these are the only characters that you have to shift right. Any other character has to go the same way it came in the input message. Okay, so first is, okay, iterate the string for int I equal to 0, I less than input message dot length I plus plus. Okay, you get the ith character ch as input message dot caret I. Okay, if this character is in the set of characters to be encrypted. Okay, so if this ch is has to be part of this, so I'll say if characters dot index of ch is not equal to -1, okay, else, that is index of ch is equal to -1, is we simply do encrypted message plus equal to ch, we add ch as it is. Okay, so if this character is found, we have to find the corresponding character after shifting it by these many numeric key places. Okay, so I'll say int index is, where this ch is in this set of characters, I'll say index of ch. Okay, move to numeric key indices. Okay, so I'll say index equals to index plus numeric key. Okay, and since index has to be within the bounds of this character, so I'll say percent characters dot length. Okay, and then we add the corresponding character at this index to my encrypted message. So encrypted message plus equal to characters dot caret at this index. That's how we get our encrypted message. And in the example, we print your new message is inverted quotes. So this out, your new message is, okay, and closing inverted quotes. Okay, I'll say encrypted message. Okay, so let's see if our encryption for the given sample that we took works or not. Enter a message, I'll say cricketer. Cricketer is what I took, right? It should be full now, something like this. Okay, I'm not sure what you pronounce that. Okay, so I'll say encrypting. You choose encryption. Key is 3. Okay, full Fanawahu. Okay, that's what we wanted. Okay, so I'll run again. I'll say my name is Balakrishna Srivastava. Okay, I'll say 3. Invalid. Why does it say invalid? It has to be invalid. Let me go back to the code, fix this. Invalid. Okay, so if I say maybe 89, invalid, say have to be say 1, right? Encryption, I'll say numeric key is 0 is not allowed. Okay, you must use a numeric key, has to be on the same line. So I'll go back to my code, has to be on the same line. Yep. Okay, so I'll say maybe 3, and this is what I get. Okay, and this was in my sample as well, and I can compare. So this was the output. Okay, all right, so you see space characters remain the same. Okay, my name is 4 characters and then space characters, and exclamation mark also remains the same. So maybe if you want to include these, you can add a space here, and then you can add special characters here. It depends upon you, but we are going to stick with the requirements. Okay, so encryption is working fine. We can try with our welcome to code with BK message. Encryption, I'll say 20, right? 20 was in the sample, right? Welcome to code with BK 20. That's what we get. That's nice. So let's move on to decrypting now. So I will have to take the same message. Okay, so I'll take decrypted message in this case. Again, you have to iterate this entire input message. Okay, get the character at the ith index. Okay, again, if the character is only the part of this characters string, we decrypt, else we add it to decrypted message as it is. Okay, because the encrypted character that we get here, okay, by shifting, will be within this characters. If any character in this decrypted message is not a part of character, so we add as it is, because it was never a part of this character string. Okay, so we do the same idea. Okay, in this case we do move to minus numeric key indexes. Okay, and in order to keep in within the limits, we say if index is less than 0, we do index plus equal to characters dot length. Okay, and then we do decrypted message is characters dot character index. Okay, and he can say your new message is decrypted message. Okay, so again clear. Let me just pull this up a little. Compile and run. I'll say my name is Balkrishna. Okay, I'll say 1, else numeric key is 10. Okay, so when I decrypt this very message, okay, and I choose the same key, I have to choose the same key. Okay, so I get my name is Balkrishna, the original message, and my Shift Cipher is working fine. Let me just run again. Welcome to Code with BK. Okay, I'll say encrypt, say maybe 100. Okay, this is my message. When I say the same message to decrypt, yep, same key. So we get this because the length of this characters is basically 26 plus 26, 52 plus 10, 62. When I use the numeric key 100 for encrypting here, this will ensure that the value of index is always within the valid indices of this characters, the character string. But in this case, we were just adding the characters dot length once. Okay, so we can replace this by this. While index is less than 0, I keep adding characters dot length so that it becomes a valid value between 0 to characters dot length minus 1. Now if I compile, run, and I choose the same message and I decrypt with the key 100, I get my message correctly. Okay, let me just run this again. I'll say Java, I'll say my brother's name, Pius, simple word. I'll encrypt, say maybe 1000. Okay, I'll run, I'll enter the same message. Okay, and I'll say decrypt with the same key. I meant a 10,000. Okay, decrypt with 10,000. I get bias. Oh, I added these inverted codes as well. No worries. Okay, so running my sample case once again, a creditor. I'll say 1 and I'll say 3. Okay, then I'll say run. I'll say this message full or whatever this is, sounds German. Okay, 2 for decrypting, and I say 3, and this is creditor. Okay, so this is your Shift Cipher in Java, right, adhering to the instructions of this assignment. And you can add this check that while input message dot length equal to 0, okay, sys out, please enter a non-empty input message. Okay, and you can read this again. Okay, you can remove this. So when I just compile, run, if I enter a blank line, it will give me another again blank line error. So if I say bias, this is okay, I encrypt with say 10. Okay, and then again if I'm trying to decrypt, not allowed, I enter this message. Okay, I decrypt with, what was the key used, 10. So I get bias bucket. Okay, so this was the Java code to implement a Shift Cipher for encrypting and decrypting, and we were able to solve this assignment adhering to the instructions. So I hope this video was helpful and you like this video. Okay, so if there's a part you don't understand, if there are doubts, please let me know in the comments. I always try to answer all your comments, and you can always let me know in the comments if there's a question you want to solve or if the concept you want to discuss. So please let me know your thoughts about this video in the comments. Please like this video, subscribe to my channel, and thank you for watching.